Does this work? Yeah, okay. Good morning. So my name is Chris Miller. I'm with Tumblr. And I want to talk a little bit about front-end at scale. Tumblr is a really large website. We receive a lot of traffic, probably the biggest website that I've ever worked on. The most number of users that see my feature and touch my code every day. And it's a little bit scary when you start to push out your code to that many users. Let me start by sort of explaining what is Tumblr. Tumblr is a platform where you can express yourself. You can do whatever you want. If you want to make a blog about Brazil or programming or weird teen things or K-pop, I mean, it's up to you. And we actually have a lot of K-pop. We have over 200 million blogs. The blog is your account. One account can have multiple blogs. A blog is your persona. A blog is where you put your content. It's how you express yourself to the world. In those blogs, we have over 83 billion posts, which is a lot of data. We're based in New York City. If you're ever in New York, please come by. We're at 21st and Broadway. We would love to have you and show you around the office. And we were founded in 2007. Today, we are about 100 engineers. In total, 260 people. We have sales offices throughout the US, but all of the engineering is based in New York. So on Tumblr, there are three main ways that you surface content. There's this thing called the dashboard. The dashboard is the application when you log in as a user, when you log in as a consumer. If you want to consume content, if you want to create a feed of content, you can follow blogs that you're interested in, and when you log into your dashboard, you'll see a listing of the most recent posts from those blogs. So you're actually able to create your own perspective on these 83 billion posts, and many posts every day. You're able to create your own perspective and your own curated set of content. You can see what you like and what the people whom you follow ultimately publish out. In order to find content, we built this thing called search. At the top, you see we have blogs that are relative to the search term that you're searching for, and then the individual posts. And then the third way, and this is actually the most traffic part of the site. The third way is this thing that we call the blog network. So when you have a blog, when you're creating content, you can surface that to people that follow you, and they'll see it in their dashboard, or you can surface it to the world. Anyone can go to your blog, unless it's password protected or something, and see the content that you create. You can do anything with the blog. The blog that you create is your space. You can theme it, you can put ads on it, you can inject weird JavaScript, really weird JavaScript. In this case, for example, this user, I wish you could see it in the screenshot. They changed the cursor icon to be a Windex, like a spray bottle. It's strange. And then there's like snowflakes falling down in the background. It's like it's 1997 all over again. But the point is, you can do whatever you want to express yourself. We stay out of your way on the blog network. If you want to put ads on it, you're more than welcome to. If you want to put JavaScript that's broken, it's your blog. You can do as you want. It's your space. So who am I? I am Chris Miller. I'm a product engineering manager. So I'm a team lead. My team works on the dashboard. So when you log in, all of the stuff that you see as a consumer. We build features, mostly front end. Probably 75% of our work is in JavaScript, CSS, front end work. And our stack, we use a lot of Backbone and obviously Lodash underscore. We use jQuery. We try to go easy on the plugins because it can build a lot of dependencies and easily get out of hand. But we do use jQuery. We've recently begun using Sass. We have a lot of CSS that we're currently porting to Sass, and most of our new features are built in Sass. We use a little bit of Velocity for some of the animation stuff. Again, that's more recent. But some of the little animations that you see when you hover, when you interact, are actually built with Velocity. And then to bring it all together on the front end, we use Gulp, which is also new for us. We were considering, so Gulp is a task runner. It's a tool that we use for building. We were stuck between Grunt and Gulp, and we were trying to decide which route to go. Maybe many of you are going through the same thing. Gulp is newer. It's a little bit less mature than Grunt. Grunt has more plugins, but Grunt is configuration driven. So to configure Grunt, you have this big JSON file with all of your configuration settings. Gulp is more native to JavaScript. So your configuration, the way that you manage the build process is actually written in JavaScript. For us, because we were integrating with a legacy code base and a legacy build process built around Ant, actually, Gulp made more sense for us because we could build some of the interactivity and the bridging to our old existing code base more easily. So we went with Gulp. On the back end, we have PHP, which services most of the requests. As I said, Tumblr's been around since 2007. It started as a small startup, grew really fast, and there was a lot of band-aids and patching and really scary things in the early days that we've had to go back and rework. But the application today is actually very mature. For example, on a day-to-day basis, I'm not really writing SQL queries. I'm interacting with model objects, and everything is provided to me through a set of libraries and a set of APIs that I interact with, mostly in PHP on the back end. We do have some specialized services in Scala, which is a JVM language. We also do have one or two things in C for very special services. Things like the Firehose, which is the real-time feed of content that users create that's written in Scala, because it needs to be low latency, very high throughput. We have an image resizer that's written in C. So historically, if you as a user upload an image, we would take that image and resize it to maybe 15 different sizes and throw that into S3. At our scale, that's a ton of content. For every image that you upload, we have 15 of those in different sizes, so it's actually very expensive for us. So we built a dynamic image resizer that would that would allow us to store one image, and then this service written in C would sit in front of that, service the request from the CDN based on the size that you need, and do it in really low latency times. The reason that we chose C is because it needs to be very responsive. We don't want your dashboard to slow down just because we're trying to save money. That's not what Tumblr is about. On the back end, so we have basically 3 tiers of data storage. We use MySQL for persistent data. We have a heavily sharded MySQL configuration, which is good and bad. When you start sharding, which means you're creating different instances of the same database for storing different ranges of data. So if you have 100 blogs, you might store blogs 1 through 50 in this database, and then in a completely separate database, maybe on different servers, maybe not, you would store blogs 51 through 100. The problem is you can't do joins because they're in different databases. You can't join across databases. So you actually, when you start sharding, you start denormalizing data. So you start duplicating data, putting it in the same place more than once. The benefit is you don't have to do joins, so when you make a query to one database, all of the data is there. waiting for you because it's in both places. The problem is if you edit a post or if you edit something that's in more than one place, you have to, as a developer and as an application, you have to track where that data is and then change it in both places. And if you don't, then you get bad things happen. We use Redis and Memcache. Redis and Memcache both are used for non-persistent data. Redis allows us to store more structured data and do some things like set manipulation, do more complicated types of queries. Memcache is just a dumb key value store. It's really fast. And then we use HDFS. HDFS is part of Hadoop, and it's a distributed file system that allows us to store massive amounts of data, which I'll get to in a second. We have thousands of servers, which was really terrifying on my first day. I remember doing my first deploy. We have a deploy tool that lets you see like how many servers it's deployed to so far. We actually deploy dozens of times per day. But I was doing my first deploy, and I watched my code go from like 1 server to 10 servers to 500 servers to more than 1,000 servers, and I thought, wow, that's really scary that my code is in all of these different places. What if something goes wrong? So we have to monitor and measure everything. Everything that we do, we monitor using Hadoop and using a thing called OpenTSDB. Hadoop is a MapReduce system. It allows us to take a cluster of servers and parse data in big chunks very quickly by distributing the work across multiple servers. OpenTSDB, you may have never heard of it. I never heard of it until I started at Tumblr. It's an open source project. It stands for Open Time Series Database. It's backed by HBase, which is part of Hadoop. It's a non-relational database. But OpenTSDB is a time series database. It's designed for storing data that is sequential. So mostly we use it for counting. So how often does something happen? What's the frequency of a particular event? Our teams are small. My team right now is 5 people. And we own the entire dashboard. So there's a lot of work, there's a lot of scope, there's a lot of, every quarter we do goals and we have to decide like what are we working on for this quarter, because we have this huge reach, but we can only work on so much stuff. The benefit is we iterate very quickly. So we're not really blocked by other teams because we have the domain of the dashboard. That's our baby. And we release early and often, usually to a percentage of users. When we do releases, we do code reviews on GitHub. Pull requests, we have to have 2 other reviewers say okay before we can deploy. And then we just deploy the code. But we release often and early and to a percentage of users. We actually release first to our own team, and then we release to the company as a whole, to this thing we call admins, which is the staff of Tumblr. And then we start to ramp up our deploys. And we do that through a thing called feature flagging. Feature flagging for us, for you too, is a way to segregate your users to certain features. So as you roll out a feature, how do you limit the feature so that only people on my team, or only people in the office can see this particular feature? It allows you to control who sees what and when. And we do this through 2 different methods. Kind of blurry. We use server-side feature flagging, which is feature flagging done in PHP to gate certain features and the way that the application responds to requests. In this example, I don't know if you can see it, but this is a thing that says if when kill dashboard equals true, then return a 503. And that's a kill switch. So at the top, like the very first thing in the server-side controller, we have this little block of code, and it checks the configuration, and it says, if kill dashboard is set to true, which it should hopefully never be, but if it is, then we stop and we throw a 503 error. So this gives us a way to turn off the dashboard if we need to. Let's say that, you know, in the data center, a row of servers catches on fire and we're suddenly low on capacity or something. Or there's a DDoS attack or something that we are unable to mitigate through other ways. We have this kill switch, so we can push a configuration change, and just like that, we can turn off the dashboard so that other services like maybe the API, which is used by mobile, or you know, the blog network, that's not the dashboard. So those services can continue to run. We also use client-side feature flagging. So server-side feature flagging we've had since the early days at Tumblr. Client-side feature flagging is something relatively new. Being that this is a more modern application and web development is moving more and more to the front end, as you all well know, we were in a situation where all of our flags and all of our gates were on the back end, and we didn't really have a way to access this data in the front end. So we built this thing that reads the configuration and pushes it out to the front end so it's available as variables. And what we can do is we can serve up, in our JavaScript, both versions of the application, so the old feature and then the new feature, let's say. And then we can just put an if statement and say, if this feature flag is set to true for this user, then show this feature. And if it's set to false, show this feature. It may seem a little bit weird because, you know, JavaScript, the application's in your browser, you could just hack it, right? Yes, you can. But most of the features that we have require data from the server as well. So although you could, in theory, turn the feature on in your browser, you wouldn't be able to get any data because your user would still be blocked on that particular feature. So you would have a feature with no data, which would not be very helpful. So what does this give us? Feature flagging gives us A/B testing. It allows us to build a feature, release it to a certain number of users, see how it responds, and then react accordingly. It allows us to run beta code alongside production code, which is a little bit scary because you're developing this new feature, you're developing this new thing, and you're pushing it out to production servers that are actually servicing production traffic. Like I said, we push dozens of times per day. As we build new features, we push it out to production. But only people who are in the certain groups, like on my team or certain people on a whitelist or people in the office, only those people would see this particular feature as it's being worked on. And it also allows us to build a kill switch. So one recent example of A/B testing is this thing that we built to inject recommended content into your dashboard. So as a user, we do calculations and computations around who you follow. And we try to guess who you might be interested in following. For example, if I follow user A and user B, and both of those people follow someone else, there's a high probability that I would be interested in that same content. So that's just one of the many approaches that we take to do recommendations. We surface it through a variety of means, but recently we started injecting a post from a recommended blog into your dashboard. And you can see that it's recommended because there's a follow button, the little blue square in the top right. Normally you wouldn't see a follow button in your dashboard because it's only stuff that you're following. But we started injecting this content into your dashboard. The question that we had was, where do we put it? So when you load your dashboard, the first post we call post 1, post 2, and so on. But we didn't know, should we put it at post 2? Should we put it in position number 5, number 9? We do infinite scrolling, so the first page that we Ajax in is like, I think 11 posts or something, maybe 15. And then after that, it's another page of 15. So where do we place the post in your feed so that it's the most engaging, so that you're the most likely to interact with it, to see it, and to do something about it? Because we want to increase follows, because if we increase follows, then you're more likely to come back because there will be more and more content that you're probably interested in. So what we did was we ran I guess actually an A, B, C, D, E, F, whatever test that we were testing positioning. So for some users, we released this feature so that it would show up at position 2, some users 3, 4, 5, and so on. And we measured how often people interact with it. So how many follows are people using this post to find new users? How many times are they interacting with it? How many times are they hitting like? We counted all of that. We threw it into Hadoop. And then alongside that, every time that you interacted with it, we also saved the position. So was it in position 2? Was it in position 5? And then we were able to see, like, what is actually the most engaging? Where should we put this post? And the results were a little bit surprising. So position 1 was obviously the most engaging. We actually didn't even put it there because that's sort of sacred. It's the first post. It's the first thing that you're going to see. We expected position 2 to be the second most engaging, position 3 to be even less engaging, and so on. But it actually turns out position 3 is more engaging than position 2, and position 5 more engaging than position 4. That doesn't make any sense. Why is that? Why would something lower in your dashboard be more engaging? So we started thinking about it. And we were looking at the dashboard one day, and we realized that when we initially load the dashboard, you usually see about 3 posts on your screen because of your browser size. And the third post is at the bottom, and it's usually cut off, but there's a follow button at the top. So for whatever reason, people are seeing from the bottom of their screen, they're more likely to see that and to interact with that than they are something in the middle. I don't know why, but that's what the numbers tell us. So this was actually really valuable data, because had we just assumed it would be position 2 or 3, we would have actually been wrong, and we would have been selling ourselves short. Additionally, feature flagging gives us the ability to ramp features. So we have a lot of traffic. We have millions of users coming at us, and we have to service those requests. But when we push a big feature, it can shift the access pattern. It can make a new route light up with a ton of traffic that we didn't really have time to prepare for. Maybe we use varnished caching, so maybe the cache isn't warm. How do we handle that? So what we do is we ramp usually to admin only, to the staff. Then we go to about 1% of users, and we watch. We see what happens. How do traffic patterns change? How does the server load change? How does engagement change? Like how does this feature change the way that users think about Tumblr? And we actually measure that, because we see when you like things, when you reblog things, when you follow things. Then we go to 5 to 10 to 25, and so on. Eventually we get to 100. But it allows us to spot problems early, and it allows us to not bring the site down, which I've done before. But that's not what we want to do, so we use ramping. And we use ramping through feature flagging. So we say, we bucket users, and we say if you're in a particular group of users, you have access to this feature. If you're not, then you don't. And we can do it by percentage, and we do it in such a way where it's not just random, are you going to get this or not? It's actually tied to your user using some hashing algorithms. And as I said earlier, it also allows us to turn off a feature completely. So we can bring down the dashboard. We can bring down a particular widget. So if we're showing, on the right side of the dashboard, we show some recommended content. If for some reason the part of the application that's showing, that's servicing recommendations goes down, we can just turn that feature off and continue servicing the rest of the dashboard. If you use feature flagging, use it carefully, because it can give you a mixed experience. For example, we have a lot of teenagers on the site, and they often say, why does my mom see this and I don't? Because my mom's a different user. This is because of feature flagging. This is because some users see some things, other users see other things. It's also easy to build in complex dependencies. So you could say, feature A is dependent on feature B is dependent on feature C. So if the user doesn't have access to feature C, or if feature C is not yet rolled out, you can't really roll out feature A. We try to avoid that. We usually don't go more than like one level deep in the dependency tree, but these are just some cautionary tales. Another thing that we do to scale the site and to control growth and to control the way that we roll out features is through error logging. So usually when we launch new features, they have bugs. Well, not my code, but my colleague's code. Just kidding. So new features usually have bugs. And in the past, server-side bugs were easy to find. You just look at the console log. There are a ton of errors that I created. Good job, me. The problem with this is applications today are moving more and more to the client side. So it's less of a problem of what is my server-side code doing, although that's still very much a problem. It's also what's the client-side code doing. Client-side errors are easy to find. We see them every day as developers. That's what we use to debug our code. We can see the errors on our own browser, right? You just open the console. The problem is, what if all of you go to tumblr.com right now and you see this error? I don't know that because it's in your browser, right? So how can I see what's happening in your browser as a developer and as someone working at Tumblr? How do I know if I release a feature and things start blowing up? Maybe it's working fine in Chrome on my box for whatever reason, but it's actually making your Tumblr meltdown. Not a good thing. The way that we historically did it was our users are very vocal. A lot of teenagers, they're very opinionated. And most of the posts that they would make, maybe complaining about the site or saying good things occasionally, would be hashtag with the tag Tumblr. So what I would do is I would roll out a feature, and I would, on one monitor, I would have like a search up of most recent posts tag Tumblr. And then I would see people complaining, and I would be like, oh crap, what did I break? And then I'd have to go like figure out like what this person is talking about, or I would watch the support queue. We have a support team that has a help desk. Maybe they would come at me and say, hey, people are complaining a lot about this feature that you rolled out. Why did you break the site? And I'm like, I'm trying. So we wanted to be more proactive. We didn't want to just see, what are people complaining about? Because we wanted to get to the problem before they even complain about it. So we built this thing called exceptions.js, and it's actually really simple. Really, it's just window.onError. So window.onError is a thing in your browser that you can connect this function to, that every time an error is thrown, this code will be executed. For what it's worth, I'm not sure if you can see that. So the first three parameters are error message, URL, and line number. The last two are column and error object. Column and error object are only available in newer versions of Chrome, and maybe newer versions of Firefox or something. But the first three are pretty much standard in all browsers. So what we started doing was we would build an array of errors that have happened on the client side. And then on browser unload, so at the, if you're going to another page or if you're closing your browser, we would AJAX that up to the server, and then we could collect it. And when the world is melting down, when your browser is on fire, smoke is coming out of your computer, because I wrote a feature that is breaking, everything. You have to be very defensive about the way that you build things. We built exceptions.js to be dependency-free. We're not using jQuery. We're not using backbone, underscore. If jQuery breaks, we still want the error. So if jQuery is broken, we can't use it to send the error. So we had to be very defensive about it. basically all that it tries to do is collect as many errors as possible, and at the last minute, even if the browser is like falling on its face and on the ground and dead, it tries to just throw the error over the fence and then hope for the best. And it actually works. So we collect the errors. We AJAX it up to an endpoint that we have. We throw it into a system called Scribe, which is just basically a log collection service. That's what we use it for. We throw that into Hadoop, which is where we actually store the content itself, so like the body of the error, the line number, things like that. But we also count frequency with OpenTSDB, so how often are errors occurring? And then we collect some metadata, like for every error, we count the frequency of the error, and then we also keep track of like how often are errors happening in Chrome, how often are they happening in Firefox, IE. And with Hive, we can query Hadoop. So Hive is a layer that sits on top of Hadoop that allows you to write MapReduce jobs for Hadoop in a SQL-like language. So this SQL, if you can see it, it's just a select from where pretty generic stuff. It feels a lot like SQL. Under the hood, it's actually not at all SQL, but Hive gives you this DSL that lets you write SQL-like queries to query Hadoop. So with this query, select DT count star as C from JS errors where DT is greater than July 15th. DT is date time. It's the thing that we partition our Hadoop logs by. So all I'm doing is I'm grouping all of the logs by date, and then I'm counting the number of events that happened on a given day. And with this query alone, I was able to figure out that we log about 1.4 million errors per day. Some days are better, some days are much worse. Depends how much code I've written that day. And with OpenTSDB, we're able to actually plot on a graph how often errors are occurring, which is so cool. Because I can sit and watch this graph, and I can do a deploy, and I can see it go through the roof because I'm a terrible developer, and I suck at my job, and I should be fired. But then I can fix it before anybody notices, and I'm like the savior. So it's fantastic. This particular graph, this is the number of, this is from yesterday. This is the number of JavaScript errors over a few hours grouped by browser type. So the green is Chrome, the red is Firefox. I think the light blue is Internet Explorer. So it's interesting. Part of the reason Chrome is so much higher, so Chrome is the majority of our users, which is fantastic. But the reason Chrome is so much higher is actually because some bots masquerade themselves as Chrome. They say that I'm Chrome, even though they're really not. So this is really powerful because I can see on your browser how often stuff is happening, and then I can use Hadoop and I can figure out what is actually happening. We actually send out an email every day that is a roll-up of all of the errors that happened that day in the frequency. So I can see like what's the most common error that happened yesterday. I have an email every day that tells me that, and it's the most common error in your browser. So cool. So this is an example from OpenTSDB. We also built a couple of really cool graphs that are a little bit more pretty on top of OpenTSDB. This is a graph of the number of 200s on the top. The green on the bottom left is the number of 500s, and the bottom right's the number of 400s. So the 200s are success codes, so the number of successful requests that we're servicing to end users. The bottom left is the number of 500s, the number of errors. So as you can see on the left, it's actually cut off the screen. There's a little spike on the left, which is really scary when that happens because it means that we're serving a lot of errors. And then on the bottom right is the number of 400s. And if you see the blue lines, that's actually deploys. So every time we do a deploy, these graphs have a blue line so that we can see, do the 500 spike? Are we servicing a lot of 503s, a lot of 505s? When that happens, if it happens near a deploy, then I can quickly see, when did it happen, and I can trace back and figure out like what's probably causing it. Every time I do a deploy, I'm always watching these graphs. You can see like the patterns throughout the day. It's really cool. And all we're doing is we're counting the number of requests that are coming from HA proxy. So we're saying how many requests per, I think this is per minute. And then we can actually see how is the application and how is the infrastructure responding. It's pretty cool. So sometimes we get it right before users do. Sometimes. It makes us feel pretty good. So we dance. This is actually me dancing, maybe in a few years. This is really what it feels like. I mean, when you see the errors spike, well, okay, it doesn't feel like that when the errors spike, but when you see the errors spike and you know that it's because of this thing, you're not just guessing, that's what it feels like. Thank you.